section. What part? Huh? What part?
Top.
Top. I mean, section should go through what members? Because I have a lot of possibilities.
CB, BF, and AB.
Exactly. So let's get a blue color. Right on the money. There you go. So this section. Now I have two possibilities. Either get the bottom part or the top part. What part should I get? The top. Because if I get the bottom, I have to first solve for reactions. So that's extra step. I said find the quickest way. So I take this top part, and that's my system. In fact, method of section is just exactly the same thing you had before. Choose your system. You just call it section because we have an imaginary cut through the structure. Now, draw FVD. If I draw FVD, well, let's number these members before I write that. So let's say this is number 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I try to draw FVD. So you can start from a point and try to circle it. So the first thing you got is the F3, force in this member, F3. Next thing you got is F2. Now you move here, the next thing you got is F4. See that? And you continue. Then you have an 8K, then you have a 4K, and then you come back to the start point. This is surface force, right? What about body force? 0. Again, you go and read the question and say, this is a truss. That means lightweight. That means, remember, gravity, mass is very small, so the body force is small. So that's all I have. Now, if I want to find F3, what should I do?
Moment around F.
Moment around
F.
F. Summation of moment on F 0. So let's work on this equation. Let's start with AK. What do I get?
0.
0,
0.
0,
0.
0, and then
1.5 times F3.
1.5 on F3. Positive or negative?
Negative.
Thank you. The next one.
Okay.
4K
Uh-huh.
times 2.
Times
2.
2. Positive or negative?
Negative.
Negative. And then 8K.
Times 2.
0.
with
0.
respect to this.
That's right, 0.
0. It goes right through this point. So that's all I have. Is equal to 0. Solve for F3. F3 is equal to 8K divided by 1.5. Negative. Negative 8K divided by 1.5. 8 divided by 1.5. Negative. Okay? So, so first of all, I get this number numerical value, and I don't have a reference, like I don't have a solution manual, anything. I want to know if my answer is correct or not. Verification, that's the step. So, do you think that I got the correct sign?
Yes.
Yeah, because you can see that the moment we load the structure like that, it's going to go this way. See that? Like that. So it's going to put some compression on this member. So both these two should be compressed. Sometimes intuition is very hard. Sometimes it's just misleading. The intuition that we have about the structure is not the actual reality. But in the simple case here, it's just so obvious. This member should be compressed. Maybe I don't know about this member. Maybe I don't know about this member. But this member should be compressed. That's what I know. So I get a negative sign. So I'm probably fine. But if it was positive, I have to come back and check my calculation. Oh, I have another question for you. This is another question here. Now, what's the fastest method to find F4? And member 4, which is this one. Let's say you start from scratch. I give this structure to you and I say, what's the quickest way to find force in member FA or F4? What do you think?
You can section the same way, except take the moment around B.
Yeah. See? That's exactly it. In fact, the interesting part about that is I want to draw this video right here. So, that's my section structure. And my system, external forces. You have F3, F2, and F4. Going this way, you have 8K, 4K, and with dimensions. So where is point B here? That's an interesting point. Point B is not in my system. It's not on a structure. It's right here. See that? This is point B. Point B is outside of the system. Sometimes it's confusing. They say you take a point that is not even in the system. Well, yes, you can. You remember the definition of moment equation? We say moment is equal to R cross F. And this R was a reference point. So this is your F, and this was R, right? But we didn't say this reference point, O, it should be on the structure. We said this is arbitrary point in the space. Arbitrary. That means that it can be on the system, like one of these points here, or it can be anywhere outside of the system. Or it can be here. You see? If that's my system, my reference point can be here. So that's you that you choose which one makes your job easier. And now, as you can see, the goal is to minimize the number of computations. Right? That's objective. So if I take this guy, and don't forget, this is a line, would be a line. So that's the missing part of the structure, you see? That is not in my system. It's external to my system. So tell me what you are right, summation moment about B, 0. Tell me to complete this line. Let's start with F4.
1.5 times F4.
Yeah, this distance is 1.5. 1.5 times F4, positive or negative?
Positive.
Positive. Then you go to the next one.
0.
Moment of F2 with respect to B, 0. Next one. F3 with respect to B,
0.
0. Go all the way, next one. 4K with respect to B.
4 times 4K.
4K times 4. Positive or negative?
Negative.
Thank you. Then, next one.
2 times 8K.
8K times 2. Positive or negative?
Negative.
Thank you. Then you come back to F4 that we began with. So that's all. Is equal to 0. So solving that for F4 would give you F4 is equal to 16 plus 16, that is 32K. Divided by 1.5. That is equal to 32 by 1.5. 21.3K. F4, 21.3K. Well, this is like a tension. This is like a tension. Do you think that we got the right number of compression or tension? Well, if you put a load like that, it's going to deform and compress this tube, right? But this one is going to elongate because it has to go like nose down this way. So this one has to elongate. That means it's tension because it has to elongate so that it can move on to the right. See that? So I should get positive. If I have negative here, I would immediately say something is wrong. Let's go back. Right? So that's the way I usually design the question in the exams. It's not going to be, I strongly recommend that you study page 247. Page 247, because we may have another quiz next class and maybe after that. And as I said, I'm not going to give you the entire question to solve it because it may take like 20 minutes, maybe who knows, 15 minutes. I'll probably ask just for one of these guys. I'm like a one-liner person. So if I give you a question, try to find one-line solution. You know what I'm saying? So, I think that's all for today. One more thing I want to say is I have been grading this last midterm and quiz and everything, but I do my best to upload the grades by end of today. So check your grade to see